Hey everyone, welcome back to the channel. So let's start with today's problem, and the problem for today is kth largest element in a BST. Okay, so you're given a binary search tree. Your task is to complete the function which will return the kth largest element without doing any modifications in the binary search tree. So let me take an example and let's see. Very bad test case has been given. Okay, 4 2 9. Let's take some example. Let's say I have one, the only thing that I can take for it. Then I can have 5, I can have 10. Let's say this is your binary search tree. Okay, now you have to find the kth largest element. The brute force or the naive approach that you can use for this is you traverse through all the nodes in the binary search tree. How you can take any order traversal, post order, in order, pre-order. You just want to have all the nodes, let's say, in one data structure, for example an array list. Okay, once I have all the elements of the binary search tree in a container like an array list, array, or whatsoever you want to take, what can I have? For example, if I'm traversing this tree in pre-order traversal, for example, so I'll have root, okay, left, right, okay, so that will be root, left, and then right. I missed something, root, okay, I'm sorry, wait. So I'm trying to write the pre-order traversal of this tree. For example, if you traverse this binary search tree in pre-order, what it would be? So root, left, right, root, left, and right. So this will be your pre-order traversal for this particular tree. Now I just want to find the kth largest element. That means, for example, if this is in sorted order, this is the first step that from my any order traversal, I store them in some array list data structure. Okay, the next thing would be I sort this list. Collections in Java, when I'm doing it in Java, I can use collections.sort to sort an array list, right? So once I get the sorted order of these nodes, what I'm going to get, I'll get 1 2 4 5 9 and 10. Correct? What do I want to find? I want to find kth largest element. So this is the largest element, this will be the second largest, this will be the third, fourth, and so on. So for example, your k given to you is 3. So which will be the third largest element? Obviously the third element from the end. So the third step would be you traverse the sorted array list from the end and you get the third element, or the other way around would be you traverse it from the beginning and you just simply find out how many total elements are there. N minus kth element would be your desired kth largest element from this binary search tree. Got it? But the problem with this approach is that first I am taking O(n) of time complexity for the traversal, then I am taking how much time does it take to sort an array list or an array by using dot sort method. It takes n log n, right? So this is taking me big O of n plus n log n of time complexity and plus an extra space. So space complexity of big O of n and time complexity of this. So definitely I can optimize this, and in its optimization you'll realize won't take anything, just a small and a tricky observation, which is if you traverse any binary search tree in order traversal, if you do an in order traversal of any binary search tree, observe what are you going to get here. Have a look. I'm just going to write the elements in order traversal. So in order traversal is what? It's left, then root, and then right. Let's see. So in order traversal of this binary search tree will get me 1, the leftmost, then root, which is 2, then its right, which is null, then I go to its root, which is 4, then I go to its right, which is 9, but I'll go to its left first, 5, and then I'll go to the root value, which is 9, and then I'll go to its right value, which is 10. So this will be the in order traversal. Do you observe something? This entire traversal itself is in sorted order. So that's the catch here. That's the catch of this entire problem. One in order traversal lets you get all the elements of the binary search tree in the sorted order, that is in ascending order. Fine. But we want to get the kth largest element from the end, right? So again, you might take another container, any array list, but rather than taking an extra space, I can do it in place. How? You saw that if I traverse in the manner that I go to left, then root, then right, I get the binary search tree in the ascending order, nodes in the ascending order. If I reverse it, first I go to right, then root, and then left, what are you going to get? Have a look here. So if I do that in that manner, let's see what I'm going to get. So I want to go to the rightmost element first, 4, 9, 10. So I'll get 10. Then you print the root node, which is 9. Then you go to its left. Now this right subtree is done. So I print 4, which is the root node. Then I go to its leftmost part. So in this subtree, the leftmost is 1. Then I print my root. Then I go to its right. Just the correction of what I'm saying, although the resultant will be same. Okay, then you print root node, then you go to this left subtree, and in this left subtree also you'll first go to the rightmost element, which turns out to be null. So you end up printing the root node, and then you print the leftmost node, which is 1. So if you just reverse the order of your traversal in a way that instead of going to the left, you first go to the right, and then you go to the root, and then the left one. So you end up getting the nodes in the descending order. So what you want is kth largest element. So if you keep a track of the nodes during the traversal in such a way that the moment you get your count, probably your count or anything, for example, I took a count variable. If count becomes equal to k, right, that means first, second, when I am at the third element which I am trying to print in this order of traversal, so that will be the element that will be the kth largest element. That's the only catch in this problem. So you can see when I was doing the conventional in order traversal, in that I was going to the kth largest element from the back. Rather, I just changed the order of my traversal, that I am now getting it in descending order. So the kth element, the third element from the beginning itself, will be my answer. So rather than counting it after I get it, why not during my traversal itself? So this is the first node, but I'm not printing it. I'll go to the rightmost. The moment I find this, I increase the count. For example, I increase my count becomes 1. Then I print 9, my count becomes 2. Then I am not literally printing, I'm just telling you during the traversal, when I am pointing to this node, my count becomes 3. So the moment it becomes equal to k, that is when I should return this value. That means this is the kth largest element of my binary search tree. So that is pretty much about it. We took O(n) of time complexity because we are traversing through each node, nothing different, and we are keeping the track of counts simultaneously. You don't have to do it again in another traversal. So that is in place. So no extra space, just the recursion stack, and that's all. So we end up doing this in big O of n time complexity. So the only trick here was that you should be knowing that in order traversal of any binary search tree gives us nodes in ascending order, that is in sorted order. Okay, we just reversed this in order traversal. Here we are doing reverse in order. That's the only difference. And reverse in order will give us nodes in the ascending order. That's the only thing we are doing. So let's go to the code and code it. What I'll do, let's take one extra function, public void, and let's name it in order, for example, reverse in order, so that you know that this is not the conventional in order traversal. Node root and int k as it is. Fine. I'll take two extra variables. One will be int count, which will I'm initializing to 0, and int answer, which will be the actual kth largest element. So right now let's initialize it to 0. It will anyway change. So if root is null, this is simple. You just have to do reverse in order traversal. Then what you are doing, you are traversing through this reverse in order function by passing root dot right first and k will remain as it is. Then you are incrementing the count by 1, count plus plus. Then you are checking if your count is equal to k, okay, then your answer becomes equal to root dot data and you return from there. That's, and then again you make a call to the function. So in order traversal doesn't need any explanation. We have already solved this question. In order traversal in binary trees, we are just reversing the order, that's all. Root dot left now. Instead of left it will be right, instead of right it will be left in the conventional in order traversal. That's all about it. Now we make a call to this function from here, r in order. This r in order doesn't look very good name, but okay, for you it is reverse in order. Root and your k is as it is, you just return answer. I've already declared them here in the class, so it will take it from there. We'll see. So that's pretty much about this question, guys. Hope you all understood this. If there are no doubts, I'll just wrap it up and see you all in the next lecture, that is tomorrow. Bye bye and take care.